These examples go with section 10.2, the hyperbola. Example 1. Given that x squared divided by 9 minus y squared divided by 4 is equal to 1, part A, graph the hyperbola. Part B, find the center, vertices, foci, and equations of the asymptotes. We're actually going to do this one backwards, because it'll be a little bit easier to graph it if we graph it as we find each of the pieces that are being asked for in part B. Okay, first thing we're asked for, the center. The center can be found based on what we see up here in the numerator. Now, nothing is being added or subtracted to x, and so in this case, the center of our hyperbola is going to be at 0, 0. And we can go ahead and put that on our graph over here. All right, the vertices are going to be on the transverse axis. Now, in this case, our transverse axis, or our main axis, is going to be the x-axis. And we know that because the x squared is actually the positive variable. Y squared is negative because it's being subtracted right here. Okay, and the vertices will occur, let's see, a squared is going to be equal to 9 in this case, which means that a is going to be equal to 3. So our vertices, since we know this is going to be on the x-axis, we're going to subtract 3 from the x-coordinate of the vertex, of the center, and we're going to add 3 to the x-coordinate of the center, which means that in this case our vertices will be located at -3, 0 and +3, 0. And we can go ahead and graph those. So there's -3, 0, and there's +3, 0. All right, foci we can find from using the equation c squared is equal to a squared plus b squared. This looks a whole lot like the Pythagorean theorem right here, but c is what we're going to need to get us to foci. We don't know c. We do know a squared, it's 9. We do know b squared, it's 4. That means in this case, c squared is going to be equal to 13, which makes c equal to the square root of 13. The foci then will be located at, and they will also be located on the transverse axis, on the x-axis. And so what we're going to do is we're going to take the x-coordinate of the center and we're going to subtract c, and we'll leave y alone. And then we'll take the x-coordinate of the center and we will add c, and then we'll keep that y. So our foci will be located at negative square root 13 and 0, and positive square root 13 and 0. Now, if we want to estimate that, the square root of 13 is going to be somewhere in between 3 and 4. So that means our foci will be located somewhere in this area right here, a little bit past 3, or -3, and somewhere out here a little bit past +3. Okay? All right. And we want to get to the equations of the asymptotes, which I'll get to that in just a second. Let me go ahead and show you. We can go ahead and graph this thing. The alternate axis, I guess we can call it for lack of a better word, which will be our vertical axis or our y-axis. I'm going to go up to and put a point right here, and I'm going to go down to and put a point right here. Notice this is right across from the center, and I chose positive and -2 because I know that b squared is equal to 4, and that means that b is equal to 2. And so these points will be located 2 units away from the center. And then one thing that I can do, and this is kind of a little shortcut, we can actually sketch the rectangle that goes through the vertices and goes through these 2 points on my axis, my alternate axis here, like so. And what this will allow me to do is now I can sketch in the asymptotes just by drawing the diagonals of this rectangle. So let's see, this is going to be So my picture will look something like this after I get those diagonals drawn in there. And now if I want to draw the parabola, I'm going to come to the vertex. Be careful, don't draw it on the foci. I'm going to go to the vertex, and I'm going to open up something that looks kind of like a parabola going to the right here, or opening to the right. And then I'm going to open up another one over here to the left. And this is what my hyperbola is going to look like. Okay, now as far as the equations for these asymptotes, now one thing I can do is I can actually count here how many up and over I've gone. And of course we know that the y-intercept here is going to be 0. But we do actually have a formula for them, and they are right over here. The transverse axis is the x-axis. These are the ones that open to the left and the right. The equations of the asymptotes are right here. Y is equal to b divided by a times x, and y is equal to negative b divided by a times x. All right, so our asymptotes, y is going to be equal to positive and negative, and we said b was 2, and we said a was 3 times x. So there's the equation for both of our asymptotes, and we're done. Example 2, given 4y squared minus x squared is equal to 16. Part A, graph the hyperbola. Part B, identify the center, vertices, foci, and equations of the asymptotes. Okay, this time our transverse axis is actually going to be the vertical axis. It's going to be on the y-axis, which means that our hyperbola is going to open up and down. And I know this because the coefficient on y squared here is a positive number. The coefficient here on x squared is a negative number. And so the transverse axis is going to go on the axis that has the positive coefficient with it. Okay, again, I'm going to do the parts of B first before I go back and graph it, and then we'll just kind of graph the pieces as we get to them or as we find what we need. Well, the first thing I notice is that this hyperbola equation is not equal to 1. And so before I can graph this, I need for it to be in standard form, which means I have to divide everything by 16 so that this guy is actually going to be equal to 1. That's going to give me y squared divided by 4 minus x squared divided by 16. This is going to be equal to 1. All right, so our a squared is going to be equal to 4, which means that a is going to be equal to 2. And our b squared is going to be equal to 16, which means that b is going to be equal to 4. And our center, again, we get this from the numerator up here. It looks like it's going to be at 0, 0 again. The vertices, remember this time it's going to be on the y-axis, and so we're going to keep the x-coordinate of the center, and we are going to add and subtract a from the y-coordinate. So we're going to be at 0 and 0 minus 2, 0 and 0 plus 2, which is 0, negative 2, and 0, positive 2. This is where we can find our vertices. So there'll be one here, and there'll be one here. Okay, the foci, remember, c squared is equal to a squared plus b squared. That means c squared is going to be equal to 20, and c is going to be equal to the square root of 20, but this is 2 times the square root of 5. Our foci will be located on the y-axis as well, and so we're going to keep the x-coordinate, and we are going to subtract c from the y-coordinate of the center. And then we're going to keep x-coordinate, and we are going to add c to the y-coordinate from the center there. That makes our foci at 0, negative 2 square root 5, and at 0, positive 2 square root 5. And 2 times the square root of 5 is somewhere between 4 and 5. So that's going to put them here and here. 2, 3, 4.5. 2, 3, 4.5. Okay. All right. Before we find the asymptotes, let's go ahead and sketch this guy in. On our alternate axis, we said b was going to be equal to 4. That's going to put me right here. We move 4 to the left and to the right of the center. We'll sketch in our rectangle. Remember, this will go through the vertices and through those points we just graphed on our alternate axis here. And that gives me a rectangle that looks like this. And then if I want to sketch in the asymptotes, remember all I need to do is graph the diagonals. Let's see, we went up 2 and over 4, down 2, back 4. We should be doing something like this for that asymptote, and something like this for this asymptote. Okay, and if we want to sketch it in, remember we go to the vertices. So here's one, and we want to open out that hyperbola toward the asymptotes. So this is going to be nice and wide. And it's going to look kind of like this right here. Of course, now all we need to do is get the equations of the asymptotes. So y is going to be equal to plus or minus. Let's go back and look at our formulas here. This time the transverse axis is on the y-axis, and so our asymptotes are located at a divided by b times x and negative a divided by b times x. So in this case, we'll have plus or minus. We said a was 2, b was 4 times x. Well, that reduces, right? Plus or minus, whoops, messed that up, sorry. There should be equals right there. Plus or minus 1/2 times x. And these are the asymptotes. Example 3, given that the opposite of x plus 1 squared divided by 4 plus y minus 4 squared divided by 25 is equal to 1, part A, graph the hyperbola. Part B, identify the center, vertices, foci, and equations of the asymptotes. Okay, we're going to do this the same way we've done the others. We're going to find these parts and graph them as we go, and when we finish, we'll have a graph of the hyperbola. Okay. The transverse axis on this problem is once again going to be vertical, and I know that because the x is the one that's negative back here. This equation is already equal to 1, so I can go ahead and pick out the pieces that I need to graph it. The center of this thing is going to be located at -1 and +4. I got this one right here because this is x minus h. This one is y minus k, and x plus h is the same thing as x minus a negative h. And so that's how I got the -1, because I had an x plus 1 here. And of course the y minus k, really we just pulled that number right there. I mean, honestly, what we're doing is whatever you can fill in for x to get 0, that's your x coordinate, and whatever you can fill in for y to get 0, that's going to be your y coordinate. Okay, let's graph this. We're at -1, +4. So our graph is going to be moving up some. All right, the vertices. The vertices are going to be located parallel to the y-axis. They're not going to be on the y-axis this time, and that's because my center is not on the y-axis. So both of my vertices are going to be located on the x equals -1 line. Okay? All right, and they can be found because we know that a squared is equal to 25, which means that a is going to be equal to 5. And b squared, we know, is equal to 4, which makes b equal to 2. I'm going to use that in just a minute. All right, so the vertices, we're going to keep our x-coordinate, and then we're going to take the 4, and we're going to subtract 5. That's one of my vertices. And then I'm going to have -1 and 4 plus 5. That's going to give me my other vertex. So my vertices are located at -1, -1, and also at -1, +9. All right, so -1, -1 is going to put one right here. And then 2, 3, 4, 5, 6, 7, 8, 9. Probably going to put it about up here. All right, so there are my vertices. The foci, we're going to find this. We know that c squared is equal to a squared plus b squared. That means c squared is going to be equal to 34. And so c is going to be equal to the square root of 34. All right. I have to move this maybe down here. Let's see. All right. So our foci will be located at -1 and 4 minus the square root of 34 and -1 and 4 plus the square root of 34. Okay, let's see. 4 minus the square root of 34 is approximately equal to it should be somewhere between 20 and 26. Okay, so 4 minus the square root of 34 is going to be almost -2. That's going to put us right in here. And 4 plus the square root of 34 is going to put us almost at 10. So this one's going to go in this area right here. Okay. All right, now let's sketch in our rectangle. Let's see, we said b was equal to 2, so that means I want to go 2 to the right from my center and 2 to the left from my center. And let's sketch this rectangle in here. And it's going to look kind of like this right here. Okay, and then we can sketch the asymptotes in there. Remember, these are just the diagonals, and they're going to look kind of like this right here. And this one's going to come down here. All right, so we're starting at the vertex, and we're going to open up that hyperbola up, and then we're going to open this one here down. Remember, go to the vertex. Do not do this from the foci. All right, now for the asymptotes. These are going to look a little bit different because this time we're going to have a y-intercept, okay? All right, our equations, our transverse axis is vertical, and so our asymptotes are going to be right here. We're going to have y minus k, which is the y-coordinate of the center, plus or minus a divided by b, and then x minus h. So we'll have y minus 4 equal to plus or minus, we said a was 5, b was 2, and then x minus h, which is going to be x plus 1. And so here are asymptotes. Okay, example 4, write the equation of the hyperbola in standard form. 3x squared minus 7y squared plus 30x plus 56y minus 58 is equal to 0. So what I'm going to do in the first step is I'm going to actually group the x's in parentheses and the y's in parentheses, and I'm going to go ahead and add that 58 over here to the other side. All right, that's going to give me 3x squared plus 30x minus, and then we're going to have 7y squared minus 56y, and this is going to be equal to 58. Now, you're probably thinking, hang on, that 56 was positive up here. Yes, it was, but when I put parentheses around it, that negative changes the positive into a negative right here, because if I distribute the negative in here, I want to get a negative 7y and a positive 56, because that's what I had up here in my original problem. All right. Before we can complete the square, our squared term has to have a 1 coefficient. That means in the first parentheses, I need to factor out a 3. We'll have x squared plus 10x. In the second one, I'm going to have to factor out a 7. We'll have y squared minus 8y. All right, and now we're going to have to figure out, because I'm going to be adding something into the parentheses here, 3 times x squared plus 10x plus something minus 7 times y squared minus 8y plus something will give me 58 plus both of those somethings. Okay, now how do I get that something? Well, I look at my middle term here, 10x. I want to take half of it, and whatever I get, I want to square it. So 10 divided by 2 is 5. 5 squared is 25, and that means I'm going to be adding 3 times 25 to this side over here. And I had to do 3 times it because the 3 is outside of the parentheses right there. I'm going to do the same thing here. We're going to take that negative 8, we're going to divide it by 2, and whatever we get, we're going to square it, and that's what we're going to add to both sides. So negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16, and so we're going to subtract 7 times 16 because the 7 back here was negative, and 7 times 16 because the 16 was put in the parentheses. Okay. The first parentheses will actually factor into x plus 5 times x plus 5, but we can write that as x plus 5 squared. The second parentheses will factor into y minus 4 times y minus 4, but we can write that as y minus 4 squared. And then on the other side, we'll put this in the calculator and see what our grand total is. And that's going to give me 21. And then remember, for this thing to be in its standard form, it needs to be equal to 1. So I'm actually going to have to divide this by 21, divide this by 21, and divide this by 21. This fraction right here will reduce. We're going to be left with x plus 5 squared divided by 7. This fraction right here will also reduce. We're going to be left with y minus 4 squared divided by 3. And of course, this fraction right here we knew was going to reduce. That's going to give me 1. And so here we go. This is what the standard form of the equation is going to look like. Example 5. Determine the standard form of an equation of a hyperbola with vertices negative 9, 0, positive 1, 0, and foci negative 17, 0, and positive 9, 0. Okay, notice this one doesn't ask us to graph it, but there is actually a graph included. That's because the graph will actually help us to see the parts of the hyperbola that we don't have, and we can actually get them by counting or by using logic. Okay, so let's first of all graph the vertices. We're going to have vertices at positive 1, 0 and negative 9, 0. All right, and the foci will be located at negative 17, 0 and positive 9, 0. So these foci are going to be way on out here. Now, the center of this thing we should be able to figure out, because the center should be located exactly halfway in between the two vertices. And since my vertices are located at negative 9 and positive 1, this length, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if we go halfway in there, that's going to take me back here to negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So the center we just found out is going to be located at negative 4 and 0. This is important. That means we know that the transverse axis is the x-axis. It's going to be horizontal. Okay, so we're going to have x plus 4 squared over, we don't know what a is yet, minus y squared, and we don't know what b is yet. And then this is going to be equal to 1. All right, so we're going to have to figure out what a and b are. Okay, now the foci. The distance from the center to a focus all right, this is going to be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units away. Let's check the other one and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, this is 13 units away as well. Okay, so that means that C is going to be equal to 13, which means that C squared is going to be equal to 169. Okay. All right, A we can find by looking at the distance from the center to a vertex, and that's going to be 5. That means A is going to be equal to 5, which makes A squared equal to 25. Well, that was pretty helpful because now I can fill in another piece on my equation here. We now know that this is 25. All right, and B we can find by using the C squared equals A squared plus B squared formula. C squared we just found, it was 169. A squared we just found to be 25, and of course B squared is what we're looking for. If we subtract the 25 from the other side, we'll have 144 equal to B squared, which is going to make B equal to 12. And so we can now substitute in for our B squared in our equation. This is going to be 144, and we've got it. There's the equation for our hyperbola. Example 6. Determine the eccentricity of the hyperbola. Part A, y squared minus x squared divided by 144 is equal to 1. And that y squared is over 25. Sorry. Okay, first thing we need to know, we need to get our c. Because we know c squared is equal to a squared plus b squared. That means c squared is going to be equal to 169. Therefore, c is going to be equal to 13. All right, for part A, the eccentricity E is going to be defined as our c divided by a, which in this case is going to be 5 because a squared is 25. A squared is 25. That means a is going to be equal to 5. Part B, we've got y squared divided by 144 minus x squared divided by 25. This is equal to 1. This looks like the same problem, y'all, but the difference is the a squared and b squared have actually changed places from the previous problem, and now the 144 is going to be my a squared. So if a squared is 144, that means that a is actually going to be equal to 12, and now we can define the eccentricity to be 13 divided by 12. I didn't have to do the c squared equals a squared plus b squared again because we have the same numbers in here. And that's all we had to do. Example 7. Suppose that two people located 4 miles apart at points A and B hear a clap of thunder. The time difference between the sound heard at point A and the sound heard at point B is 16 seconds. If the sound travels 1,100 feet per second, find an equation of the hyperbola with foci at A and B on which the point of origination of the sound must lie. Okay, so the foci are our two observers, and they are going to be located at negative 10,560 and 0 and positive 10,560 and 0. The distance d1 minus d2 should be equal to the speed of sound traveling times the amount of time it took to get over there to observer B there. And in the calculator, that is going to give me 17,600 feet. Okay, we are also given the fact that the center of this hyperbola is going to be defined to be at 0, 0. Now, one other thing we know about the distance d1 minus d2, we know it's equal to 2 times a, so it's equal to the length of that transverse axis there. So we can actually figure out what a is by solving the equation 2a is equal to 17,600. And I'll just divide both sides by 2 here, and we will figure out that a is actually equal to 8,800. Since our observers are standing at the foci, and we know the foci are negative 10,560, positive 10,560, we can pretty confidently say that C is equal to 10,560. We can now find our B by using the C squared equals A squared plus B squared. So 10,560 squared is equal to 8,800 squared plus B squared. And after we put this in the calculator, y'all, we're going to figure out that B is actually equal to 5,837. And no, that didn't actually come out nicely. There was actually a decimal back here if you're curious. We've got, let's see, if I round that up to 3 decimals, it'll give me 0.260. And there was actually some more back there behind it. But since our numbers are so large, the 5837 is going to be enough here. Actually, we have enough to write our equation because remember, the equation of the hyperbola is going to be x squared over a squared minus y squared over b squared is equal to 1. We've got our center at 0, 0, so we know we're going to have x squared and y squared. We now have an a and a b. So x squared divided by 8,800 squared minus y squared divided by 5,837 squared is equal to 1. And I'm just going to leave them like that because those numbers squared are going to be pretty long there. So there's the equation for our hyperbola.